Welcome back, Year 5. In today's math lesson, we are going to be dividing decimal numbers by 10. Last week and yesterday, we worked on multiplying decimal numbers by 10, 100, and 1,000. So division is simply the opposite. So you're going to find that once you have mastered multiplying by 10, 100, and 1,000, division is a breeze. So we're going to be using our understanding of place value to develop fluency, that's accuracy and speed, in dividing decimal numbers by 10. Hello, Year 5. As you can see, I'm still messing with a new way of recording things. I just really didn't like having to hold the tablet because I found that my hand would shake a lot, so I'm trying this way so that it's a lot more stable. Now, I'm still going to be working out things on the board, but as requested, you're going to be seeing the textbook pages on the left-hand side of your screen. Now, before I start, just to clear things up, I have these in so that I can hear what I'm doing, and this in front of me is my microphone so you can hear me. So please just ignore this and don't think I'm listening to music while I'm teaching you. Alright, so I'm starting at the Discover portion in the textbook, and we're dividing decimals by 10. And as you can see in that image, Danny and Lexi have measured their hand spans. Now, a hand span is just the distance from your pinky to your thumb. So a handprint, basically. They're measuring the width of their hand. Danny has said, I wonder how wide just one of my hand spans is. And he has said that because when they measured, what they did is they put down 10 hand spans, or 10 handprints. So we can see that the measurement for 10 of Danny's handprints is 1.5 meters. And for Lexi, it's 0.9 meters. So let's see what the questions ask us. 1A. What is the width of one of Danny's hand spans? Just one, because remember we've only seen 10 so far. And we're looking for that in meters. So 1A, well, I can tell right away this is going to be a division problem because we have 10 hand spans, and for us to find one, we need to take that full measurement, the full 10. I'm trying to make you guys see both my hands. Where are both my hands? There they are. So let's say this is the length of the 10 hand spans. If I break this length up into 10 equal sections, I'll have the length of just one. So I need to split. So 1.5 meters split or divided into 10 equal parts because he has 10 handprints laid down. Well, how do I go about doing that? What do you think? Take a moment to think about it. Because dividing 1.5 by 10 is not something I can really just imagine. Think of the trick we did with multiplication. When we multiply, the numbers move over to the left, one place to the left, because then they become 10 times greater. So when we divide, we do the opposite. They move the other way. I'm going to be using the decimal trick because I find it's really handy when you don't have one of those sliding boards. So I'm going to just make my decimal point move, even though we know the decimal point doesn't really move. So the trick here is that when I move the decimal point, I need to keep in mind, since I'm dividing, the number must get smaller. So if I move the decimal point back, my number is going to get bigger. It will turn to 15. So I need to move it forward so my number gets smaller. And I'm moving it only one space forward because 10 has one placeholder. So the decimal point moves one place. So my answer is going to be 0.15. The 1 and 5 now appear behind the decimal point. So that is what I get when I divide 1.5 by 10. So I take his 10 handprints, the length of the 10 handprints, and divide that into 10 equal sections, and I'll get the measurement for just one handprint, which is 0.15 meters. Let's try the B part now. This is going to be a multi-step problem. It says, in meters, how much narrower or smaller is Lexi's handspan than Danny's is? Well, for this problem, the first thing I need to know is the length of, or the width of Lexi's handspan and the width of Danny's handspan. Fortunately, I already worked out the width of Danny's. It's 0.15 for one handspan. But I don't know the width of one of Lexi's handspans yet. So until I know the width of her handspan, I can't compare it to Danny's. So I need to divide to figure out the width of one of her handspans. So for 10 of her handspans, it's 0.9 meters. So if I split it into 10 equal groups by dividing by 10, I'll find my answer. Again, I need to move that decimal point one place to the left. The decimal point is moving to the left, but the numbers are moving to the right, so that the number becomes smaller. So now I have decimal point 0.09. So 0.09 meters. So up here, Danny, let me put his name above it. Danny's handprint is 0.15 meters, or 15 hundredths of a meter, whereas Lexi's is only 9 hundredths of a meter. So how do I find the difference in their handspans? Well, I gave you a clue there, the difference. I must subtract. So for me to work this out, I need to start with Danny's handspan, 0.15, and take away Lexi's handspan, 0.09. And that will show me the difference between the two numbers. 5 take away 9 I can't do, so I steal from the 1. Oops, that looks like a G. Turns into 0, 5 becomes 15. 15 take away 9, 6. 0 take away 0, 0. Put back my decimal point and another 0. So the difference in their handspans is 0.06 meters. That's my final answer. So Danny's handspan is 0.06 meters bigger than Lexi's, or I think the question actually asked how much narrower is Lexi's, so it's the same thing. Her handspan is 0.06 meters narrower than Danny's. Alright, time to move on to the think together portion. So we're dealing with the same types of problems. We're dividing by 10, and we're using decimal numbers. Here it says, Toshi makes a line of 10 footsteps. Same idea. And his line of 10 footsteps is 2.6 meters long. How long is each of Toshi's footsteps in meters? And they provided us with a place value grid to help us understand this problem. So I am not going to be using the place value grid for this because I know at home you guys don't have one of those slidey charts or place value grid to use unless you draw one up. So I'm still going to be using that decimal trick. So I can see there, if I need to work out how long each of his footsteps is in meters, I just need to divide the current length, which is 2.6 meters, into 10 equal parts, because all his footsteps are the exact same, it's just his foot. So question 1 for Think Together, 2.6 meters divided by 10. So that's the total length divided by the number of steps he took, or footprints that he put down. How do I divide this by 10? Remember, I'm making it smaller, and to do that, I can move the decimal point one place forward. I'm moving it only one place forward because the number 10 has one placeholder. So it's just the opposite of multiplying. So I move my decimal point, and it's now going to appear in front of the 2. So my answer, 0.26 meters. So each of his footsteps is 0.26 meters long. Now I can work this backwards. That means if he takes 0.26 meter steps 10 times, he's going to end up with 2.6 meters. So that decimal point will then move the other way. Or I could make it super complicated and add this up 10 times and see if I get to 2.6. Trust me, you will. So you don't need to feel the need to try working that out. Quick side note that just occurred to me. If you have not yet done the multiplication videos, the ones on multiplying by 10 and multiplying by 10, 100, and 1,000, please go back and do those first, because this won't make very much sense to you, this trick, if you have not seen those videos yet. Now on to question 2 from the Think Together section. It says, work out the missing numbers. Again, they provided a place value chart. If you like to use that and you want to draw the arrows in it, you can absolutely do that. Question A, 0.92 divided by 10. Well, I'm going to apply my same strategy. I know the number is going to become smaller because I'm dividing, and when I move the numbers one place to the right, it becomes 10 times smaller. So I can just imagine that I've moved my decimal place in the other direction one time for the one placeholder, making my number smaller. So I moved it one place, so now the decimal point is going to appear in front of the 0. 0.92. 0.092. I always like to put something in my ones place because It's something that a math teacher always told me. You never want people to think that this decimal point doesn't exist. So if you put the 0 here, they'll know, oh, it's no mistake that this little dot appeared on the page. They recognize that it's a decimal point. So I always put something in my ones place, and I encourage you to do the same. So as I can see, my number got smaller. It went from 0.92 to 0.092. And it works the same going backwards. If I were to multiply this by 10, it would go back to my starting point. Let's try the next one. 53.6 divided by 10. Again, my number is becoming 10 times smaller, so I'm going to move my decimal point one place for my one placeholder. I must move it so that my number will become smaller. So now the decimal point will appear in between the 5 and the 3. So instead of 53.6, I'm only going to have 5.36. And I know this makes sense because in my starting number I had 50 as one of the parts of my larger number, 53.6. So if I just think about this 5 as being 50, and I divide 50 by 10, I end up with 5. And I do have the value 5 in my answer. C, 95 divided by 10. Don't get fooled because you don't see a decimal point. Where is the decimal point always located? In between the ones and the tenths place, or after the ones place. So I know my decimal point must be right here after the ones place. So if I'm going to make my number 10 times smaller, I'm going to move that decimal place over one spot. It will now appear in between the 9 and the 5. My answer, 9.5. So it becomes 10 times smaller. This 90 divided by 10 leaves 9. So I know my answer makes sense. And it works backwards. I can multiply and get back to 95. Now the final one I'm going to consider with you is D. Some number divided by 10. Oh, I just realized this kind of looks like a subtraction sign. I need to make these a little bit brighter. Oh no, I hope that hasn't confused anybody. So, the last one I'm considering, D, some number divided by 10 equals 5.86. How do I work this one out? Well, I know where I end up, so I can work my way backwards to get to my starting point. What's the opposite of dividing? Multiplying. So we did questions like this before when it was a multiplication sign here, and when we worked backwards we had to divide. So now that there's a division sign, when we work backwards we have to multiply. So I know my starting number must be bigger. So my decimal point is going to move the other way. So it's moving one place because it's still by 10. Shift it one place in the other direction, it ends up between the 5 and the, in between the 8 and the 6. So now I have 58.6. How do I know my answer is correct? Well, it works both ways. If I move my decimal point forward one space to make my number 10 times smaller, I'll end up with 5.86. And also, 50 divided by 10 is 5. So I see that elements in my answer are correct. Now I want you all to figure out E and F on your own. So E is a simple division problem, and for F, you're going to have to work your way backwards just like I did in D. All right, Year 5, now it's time for your independent work. Today it's taken from pages 45, 46, and 47. I expect that everyone will be able to work out pages 45 and 46 with very little trouble. Page 47 is a bit more challenging. As you would have noticed, the third page of independent work is always the most challenging. On that page, page 47, there is some background knowledge that you have to have in order to solve the problems. And that knowledge is that 1 liter is 1,000 milliliters. You must also know that 1 kilogram is 1,000 grams. So, if you were to have 100 milliliters, you would need 100 milliliters 10 times just to make 1 liter. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So it takes 1,000 milliliters to make 1 liter. With that background knowledge, you can work on question 7. Similarly, in the second part of question 7, the B part, it asks about 200 grams of cocoa. Well, you're going to notice that the little container of cocoa says 1 kilogram. Again, it takes 1,000 grams to make 1 kilogram. So that's 10 groups of 100. 100 grams, 200 grams, 300 grams, 400 grams, all the way up until you get to 1,000. So you'd be applying that skill of dividing by 10 to work out those relationships. The challenge isn't particularly hard. It's just a 2-step problem. So take your time and think carefully about it. And as always, I want you to do the reflection. It says, explain how to divide a decimal number by 10. I don't want you to just show me an example. I want you to explain in words how you go about doing it. So think back to all the times I've explained to you about moving the digits. Think about how you would put that into a sentence. As always, when you're done, take a picture of your work and send it to me. Stay safe, Year 5. I'll be seeing you soon.